Okay, so I'm just going to go over some of the problems from section 10.2 in the WebWorK. So in this problem, you're given parametric equations for a curve, and you're supposed to find dy dx. So we're just going to use the our formula for dy dx, which we know is dy dt over dx dt. So we're taking the derivative of y, and that's a product, so we're going to use the product rule. So we have the derivative of t, which is 1, times e to the minus 9t, and then t times the derivative of e to the minus 9t, which would be minus 9 e to the minus 9t. And then in the denominator, we have the derivative of x, and that's just 8 e to the 8t. And we want to simplify that a little bit. So in the numerator, we can factor out e to the minus 9t. So that would give us a 1 from the first term, and then a minus 9t from the second. So we have that upstairs, and then 8 e to the 8t. And we could take 1 minus 9t over 8 and then combine the e terms by subtracting the exponents. So this would be e to the minus 9t minus 8t, so minus 17t. And you could leave it like that, or I'm just going to go one step further and go 1/8 minus 9/8 t times e to the minus 17t. Okay, so that means, so there's my first derivative. I'm just going to put a box, a red box around it. Now, so for the next part, I'm supposed to take the second derivative with respect to x. And I know that to do that, I take the derivative of the first derivative with respect to t. Right? So I'm going to have the derivative of this and that gets divided by dx dt. So that's e to the 8t. Okay, so that's the computation that I need for the second derivative with respect to x. So in the numerator, I again have a product, so I'm going to use the product rule. So I'm going to get minus 9/8 e to the minus 17t plus 1/8 minus 9/8 t times minus 17 e to the minus 8t. So let me just shrink this down because I'm getting running out of room here. Okay, so so that would be e to the minus 17t. Okay, so I think that's right for the product rule. Minus 9/8 e to the minus 17t plus 1/8 minus 9/8 t times minus 17 e to the minus 17t. And then downstairs I have 8 e to the 8t. So again, let's factor out e to the minus 17t from the numerator, and that's going to give me a minus 9/8, and then a plus, minus 17/8 plus 9 times 17, which I guess is 153, over 8. Okay, I think that's right. Over 8 e to the 8t. And then, well, we can bring down, if we multiply everything through by 8, we're going to have a 64 downstairs. If we combine the e terms, we're going to have e to the minus 17t minus e to the minus 8t, divided by e to the 8t, so e to the minus 17t minus 8t, so that's e to the minus 25t. Yes, and then in the bracket, the 8 is already gone, so we're going to have minus 9 minus 17, which is minus 26, plus 153t. So again, let me move this. And then we're just going to have 153t minus 26. So I think that's right. Okay. And then we just are asked, for example, at t equals 0.4 is the slope of the tangent line negative, positive, or 0. So that means we know that the slope of the tangent line is given by dy dx. So we just have to plug in t equals 0.4 in there. And we get, well, let's use this expression. We put 0.4 for t, so 9 times 0.4 is 3.6 over 8 e to the minus 17 times 0.4, and without computing I can tell that that's going to be negative because the e part is positive and the 8 is positive, so it's just the sign of 1 minus 3.6, which I know is negative. So, so it's going to be negative. And then for part D, is the curve concave up, down, or an inflection point? Well, that's given by the second derivative, so I'm going to use this. And I'm just going to plug in t equals 0.4 in there. So that's e to the minus 25 times 0.4 over 64 times 153 times 0.4 minus 26. So it's really just the sign of this that I need. Let's see, this is 12, 21, 2, 4, 5, 6. I think that's 61.2 minus 26, and that's positive, so I think it's going to be concave.